hit the boundary.
Hit the boundary.
Then this thing hit this thing 嘛，然后它转不过去。
Oh, I see. So how? Yeah, I'm going to be the camera.
No, just on again. On.
Oh, so I just press the blue button. Okay, sure. Okay.
But you turn this thing, turn so that it don't hit the boundary.
Okay, sure.
Because you come here, is it?
Yeah, I think so.
You just turn this thing off.
Oh, okay. So I'll try to minimize my movement.
Yeah.
Okay, can. Alright, so got it now? Got this question. Okay, let's go on. You have drawn the dot cross diagram for the disulfur dichloride. Okay, then in D4, I'm sure you'll be good in explaining the definition for isotopes. So they are atoms of the same element, that's 1 mark. Same number of protons but different number of neutrons, 2nd mark. Right? So what is the value for the relative atomic mass? What did you get? What must you do? Remember? What's the method? In your syllabus, you learned how to calculate the relative atomic mass of chlorine, right? What did you do? You take 25% times 37, right? Because 37 is actually the AR of the isotopes of chlorine. Then the other one is 35, right? And you take 75% times 35 and you sum it up together to get 35.5, remember? So you must use that same method to work on these questions as well. It's just that these questions, they have told you that iron has more number of isotopes. There are 4 types of isotopes. So you see they've given you abundance 5.8% for Fe54. So you take 5.8 out of 100 times 54 plus 91.72 out of 100 times 56 and do the same for the other two, add it all together. That's how you find the relative atomic mass. You try it? This one must know. Yeah, important.
Must it be like 5.80 over 100 times 54? Or together?
Yeah, correct. That means you take 5.8 over 100 times 54 plus 91.72 over 100 times 56 plus 2.2 over 100 times 57 and so on and so forth. Then you just sum up everything. Neon, what is the mass number for neon? 20, 20. Then okay, now another type of questions that are related to isotopes, which you need to know is that they will give you the atomic masses of the 2 isotopes, and they want you to find the relative abundances of the 2 isotopes given the relative atomic mass. Alright, given the relative atomic mass. So, like for example, neon has 2 isotopes, Ne20 and Ne22, and they tell you that the relative atomic mass, which is the average number of this relative atomic mass of the neon, is 20.2. Okay, so what is the percentage abundances of each isotope? Right? So if you want to find the relative abundances of each isotope, you have to work it out in terms of x, right? Because you do not know the percentages, but you know that both the percentages will sum up to be 100%. Alright, so what you need to do is you can let X percent be the abundance for Ne20 and automatically 100 minus X percent will be the abundance for the Ne22. You see that? Okay, then what do? You form an equation in terms of X and you have to solve for X. Like this. You see 20.2 will be equivalent to X over 100 times 20 plus 100 minus X over 100 times 22. Do you understand? So you can ask such a question whereby they phrase it the other way, whereby they give you the relative atomic mass, they want you to find the percentage abundances. This kind of question also need to know. Alright, so when you solve it, could you solve all this algebra? Okay, very quickly just solve the question. There are many things to remember, to learn in the subject. So at times when you do a recap, it's also useful. It helps you to remember what are the important things for the earlier chapters. Okay, what's your value?
90%.
Yeah, for the one with Ne20, right? Yeah, so that's why you see your relative atomic mass, which is 20.2, is actually closer to the for the Ne20. Get that? Okay, because it has a higher percentage abundance. So 90%, the other one is 10%, right? Okay. Actually, this neon 20 versus neon 22 is a standard kind of questions which you will see in most of the exam papers. That means neon 20 is fixed to have an abundance of 90% and neon 22 is fixed to have a percentage abundance of 10%. Just like chlorine 37 is 25 and chlorine 35 is 75%. Okay? Yeah, so another example to share with you. Now B5, since you have not done the periodic table, we shall put on hold for that first. B6 is on the chapter on matters. So very simply for part A, use the above structure to explain how tungsten conducts electricity. And we know that for any matters to conduct electricity, they need to use the C of mobile electrons. So you're going to say that tungsten has a closely packed and orderly arranged positive ions. Tungsten has closely packed and orderly arranged positive ions which are surrounded by C of mobile electrons. These electrons carry charges and conduct electricity. These electrons carry charges and conduct electricity. Okay, now what is a common mistake where students make for this question is that straight away they said that the tungsten has C of mobile electrons to conduct electricity, but they didn't highlight the structure of the tungsten. But the question wants you to highlight the structure of the question, tungsten. So that's why the first part of the answer, whereby you said that tungsten has a closely packed and orderly arranged positive ions surrounded by the C of mobile electrons, this statement is used to explain the structure. You understand? Alright? So that's how we get the 2 marks. Okay, then in part B, many physical properties, I can talk about high melting points and boiling points, high density, It is malleable and ductile. It can be used as a catalyst to speed up the rate of reaction. Okay. Any questions so far? Alright. Okay, let's move into question B7, which is the QA questions. Alright. So you have a flow chart. I haven't done this at all. Yeah. Okay, so you have a flow chart and you're supposed to fill in all the blanks. You're going to identify the substances, 6 of these substances. Okay, 5 minutes, you look through the flow chart first. You still remember your QA? Right, so your QA you have 2 parts, right? Test for cation ions and test for anions. Alright, so remember we said that for the test for cation ions, the colored ones we will put it as one group, then the others like the white ones we will just you can memorize them as another category. So remember your amphoteric oxides, which are the zinc, lead and aluminium. Yeah, so if let's say you need to test any of these amphoteric cation ions, they will all have the same observation. Like for example, if you use sodium hydroxide to test for zinc, aluminium or lead, they will give white precipitate which will be soluble in excess. You know why soluble in excess? Because they are amphoteric. So they will still react with the sodium hydroxide, which is an alkaline, when we add it in excess. So you put them together, you group them together, then you remember it easier. The rest are all coloured lah. Not siao, Kylie. Okay, so
Oh my god.
you know,
From you. Where from me?
your reaction so funny, Kylie. It's like it's a very scary thing, is it? Aiya, don't bother already. I also cannot. Okay, then I don't bother. Okay, so I press already but cannot. And it's still recording. Everyone siam away from the camera. Oh.
What? You
No.
They never on it.
Sorry?
Yeah.
But it's still recording, no?
Yeah, just on the
Oh, you have to press longer, press and hold.
Yeah. So then you must try again. Press your face. Then you try your face. You can target your hand, no?
Sorry?
You can like target your hand. You just want to show your hand.
Oh,
Yeah, right
yeah.
there.
That's very advanced. Okay, sure. Yeah, so I was saying that for the other coloured cat ions, very funny. Okay, so I was saying that the other coloured cat ions, if it's blue, it will be copper 2 lah. Then if it's iron 3, it will be reddish brown. Iron 2 will be dirty green or green. So that's how you can remember it easily. Alright, then the other thing is, remember we talked about copper 2 ions. So for copper 2 ions, sometimes the description of the colour can be can have a varieties of description. Like for example, it can be described as blue green or light blue. So if you or light green, if you see this kind of description, usually it is referring to copper 2 carbonate or copper 2 nitrate. Right? In some questions, they describe copper 2 nitrate and copper 2 carbonate as blue green, light green. So you must go and read further in the questions to find out what other information can we conclude that this must be a copper 2 compound and not be confused with the iron 2 ions. Understand? Okay, so they will have more than sufficient information and questions for you to identify, so just read carefully. Okay, anyway, for the anions, the test for the carbonate will be very straightforward. Just use the acid. So if it gives effervescence, you test for the effervescence with the lime water, and if the lime water turns into white precipitate, it shows that there's carbon dioxide. Then it must be the carbonate, right? Otherwise, to test for chloride, iodide, you must use the silver nitrate solution with the nitric acid. Okay? What about sulfate? You remember how to test for sulfate?
Add silver nitrate.
that one is chloride and iodide. Barium nitrate. Okay, so you react it with the barium nitrate. Then what other ions? What about nitrate ions? So nitrate ion is the one with the aluminum foil one, right? Yeah, so you can use either aluminum powder or the aluminum foil together with the sodium hydroxide. Alright, and then test for the ammonia gas. Alright, so what will your answer? S. Let's see, what is S? Now this is considered to be one of the not so easy questions, especially when you have a sample that consists of a mixture. Right, like in this question they say this is a mixture, there are 2 parts of the sample, right? Then you need to identify 2 parts. Yeah, so not so straightforward. Usually you start from the bottom and work it out to the top. So if you were to look at when I sit down I can detect my motion, okay? So if you look at the bottom part, they talk about the pungent gas, right? So identify gases will be the easiest step to do first. So pungent gas must be the ammonia, right? So we have V as ammonia gas. Then you work it out. You realize that, okay, this pungent gas ammonia is given off when we heat the aqueous ammonia reaction and there's no PPT. So what is this then? How come when we add aqueous ammonia there's no precipitate, and yet it's able to give off ammonia gas when we heat it up? So it's quite likely that it must be the ammonium ion, right? Okay, because the cat ion ammonium is the only one that has no reaction or any observation with the sodium hydroxide. Okay, so we concluded that there are ammonium ions in S. Then what about the N ion? And that's why you look at the silver nitrate with the nitric acid. It gives white PPT, so it shows that there are chloride ions. Make sense? Then you put them together, S must be the ammonium chloride. Okay, so if X is ammonium chloride, you have identified that, then can we conclude what is the white precipitate W? Kylie, what's your answer? White precipitate. They are chloride ions, so the white PPT will be the silver chloride. Remember? Yeah, because we use silver nitrate to detect the presence of chloride ions. Yeah. Okay, now we're going to look at the other part of the sample, the other part of the mixture. So if you read from the bottom to the top, there's obviously carbon dioxide gas, which is the gas Z. Then in order for carbon dioxide to be present, means that there must be carbonic ions present in X, right? Because we added the hydrochloric acid to X, then it gives off carbon dioxide. So X must have the carbonic ion. But what about the cation ion in X? So then you look at the column that says, when the aqueous ammonia is added to the solution Y, there's white PPT which is soluble in excess. Do you remember which cation ion?
Amphoteric.
Yeah, you're right, amphoteric, but which one? There are three of them. Zinc, okay? So it will be zinc 2 plus ions. So there will have zinc 2 plus ions in X and carbonate in X as well. So therefore X must be the zinc carbonate. What about Y? So what is Y? Since you've added the hydrochloric acid to zinc carbonate, then Y will be the zinc chloride, right? Okay, so that's zinc chloride.
How come
Yeah.
it cannot be lead or like the aluminium?
Good question. Because if you use aqueous ammonia for lead and aluminium, they will give the precipitate which is insoluble in excess. You can refer to your list. Yeah. Okay. So that's for part A. Then in part B, this question very important. So seems like we can use filtration method to separate S and X because X is an insoluble substance. What is X anyway? Zinc carbonate. Then S is ammonium chloride. And we know that all carbonates are insoluble in water, right? Except for group 1 and ammonium. So actually we can do filtration. But the thing is, other than filtration, what's another method? So you have to recall what experimental method have you learned in the first 2 chapters? Filtration, distillation, what else? Okay, magnetic attraction, what else? Chromatography, fractional distillation, there's one more. In fact, 2 more. Separating funnel. There's one more also. Remember you learned sublimation? Okay. So actually the answer for this is sublimation. Why? Because ammonium chloride is a substance that sublimes. Okay, it is sublimation for this question because ammonium chloride sublimes. Can? Right?
Is there a question we need to explain?
You don't have to explain, but you must know sublimation. So that means sublimation can only be used to separate mixtures if one of the substances can be sublimed. So do you all remember what examples of compounds that sublime? You learned in primary school is iodine, right? Yeah, what else? Dry ice. Dry ice is the solid carbon dioxide. And then now you have one more to your list, which is the ammonium chloride. There's a few more, like, you know, mothball. Mothball is called the naphthalene. So naphthalene is another substance that will sublime as well.
spend.
Okay, N naphthalene. naphthalene. Alright? Okay, so remember this. Now for question B8, it's pretty easy. So I'll give you the answers for B8 first. Apparatus to measure the pH of the soil. You can have answers like the pH meter, pH sensor. Okay, and then you can see that how come the soil, the pH of the soil will always be decreasing. That's because of the acid rain. Okay, acid rain, or due to the excessive use of the fertilizer, that will cause the pH to decrease. This question is under the acid, bases and salts chapter. So how do we neutralize the acidity in the soil? What kind of substance do we add? Okay, we remember we have to add the limestone, or we can add the slate lime. Limestone or the slate lime. Okay, and then for the last part, if you look at the table given, you have the barley, right, as the crop to be most suitable to be grown in the farm. Right, that's because from the 4th to the 6th year, the pH is close to approximately 7 to 7.5. Yeah, so that's why it matches to the barley. Yeah, okay. Then one more question is, can you use the litmus paper to find out the pH value of a substance? Cannot, right? You know that litmus paper is only used to identify or differentiate between acid and alkaline. Huh? Then if you want to find the pH of the substances without using pH meter or a pH sensor, what other method can you use?
pH indicator.
What indicator?
Universal.
Universal indicator. Only universal indicator.
The
Right.
mid-
The
Of
meter
orange.
orange cannot. Meter orange, phenolphthalein, all this cannot be used to detect the pH value because they are indicators that can only work within a range of pH values. So if you don't use those electronic devices like the pH meter, right, then you have to use your universal indicator paper. Alright, it's a white strip of paper. Just dip it into the substances and it will change color. Alright, so let it stabilize first. Then after that, when it's dried, right, you use that piece of paper and match it against the universal indicator chart. Then you'll be able to find. It will not give you a very precise value like those pH meter lah, but at least it gives you a range, like a small range and an estimation of the pH value. Do you understand? Alright, so besides the pH meter, this will be the second best choice of method that we can find out the pH value. Alright, but we cannot use meter orange or screen meter orange or the phenolphthalein to find out the pH value because their working range is too wide. Yes, but of course you can use these indicators to detect between the acid and alkaline. Okay, so just take on this are important points, nothing much already. Okay, let's go into the section C now. Now for section C, we'll talk about question C1. You can't do C2 because that's under the periodic table, so you can only do C1, C3, C4. Okay, now for C1, talks about this sodium phosphate. Alright, a soluble salt is made by reacting phosphoric acid with a base, and definitely the sodium phosphate is a soluble salt because we said that all the group 1 compounds. Alright, all the group 1 compounds are usually soluble in water. So part 1 is easy. Which ion is responsible for the acidic property? Alicia, what's your answer? Which ions is responsible for the acidity in phosphoric acid? What ions? For acid, right, these ions will be H+. Then for alkaline, the ions will be OH-. Okay, so that's what it meant by the ions that are responsible for the acidity and the basicity of the substances. Okay, then 2 reactants that are used to prepare the sodium phosphate. First of all, how would you prepare sodium phosphate? What method do you use? It's a group 1 soluble salt. Yeah, good. Titration. Because titration is used to make the group 1 soluble salt or the ammonium soluble salt. Okay, then there are another 2 more methods, right? Precipitation and adding excess. So precipitation is used to make the yes, insoluble salt. Okay, insoluble salt. And then the adding excess is used to make the non-group 1 soluble salt. Okay, so these are the methods. By the way, in part 2, what will be the 2 substances that can be used? Any idea? So if you want to use titration method, then we have to carry out the neutralization reaction. Yeah, so you can use an acid with an alkaline. Yeah, so to get the sodium phosphate, Kylie, what's the alkaline used? Sorry? Alkaline. If you want to make sodium phosphate.
Sodium hydroxide.
Correct. Okay, sodium hydroxide and acid will be the phosphoric acid. Okay, phosphoric acid. Okay, now part 3 important. Just curious, how would you get the ionic equation for this reaction? How do you think we should get the ionic equation for this reaction? Now you've already done part 1, part 2, and you understood that this is a neutralization reaction. So for all neutralization reaction, they will only follow one ionic equation, which is the H plus OH minus to give H2O. So for this question, you just have to write that down. You don't have to go and write the full equation, break them into ions. Okay, but state symbols have to be given. Alright, so H plus OH minus to give H2O, which is in the liquid state. Then H plus and OH minus must be both in the aqueous state. Get it? Okay, then part 1, in part B, you all try this part B. Given that lead 2 chloride is an insoluble salt. You try it first. Try and get some materials. Could you all try this C1 part B and then you move on to C3, which is a QA. Alright, we can discuss on that. We'll finish up this before we leave, so we end a little later. Right? That's interesting.